So I'd just like to say good morning to everyone who's just joined us or just about to join us. I'll just give everyone a few minutes to just to see if there are going to be any latecomers, and then we'll start about 1:09. 1:10. Right, so it's 10 a.m. and we'll start just to make sure that we don't run over time. So just a quick introduction. My name's Richard, and I'll be running the presentation. So just as a little bit of introduction, I represent a software company that we sell Sonar Cube plugins for web message record developers. Sorry, excuse me, just a bit of a cough. Our main product is called MP Precise or MB Precise. So just a quick agenda. So just going to have a quick chat about what we're trying to achieve today, or what we're trying to achieve with the product. So essentially, Sonar Cube is an environment or an ecosystem that allows us to improve our code quality. And so we're just going to run through some terminology first, just to make sure we're all talking about the same thing. So if you come from another background, or a development background, but using another language, you're probably familiar with some of these terms, but I'll just quickly go through them. And these are available on general wikis. So in the Java world, there's a thing called FindBugs. So essentially, it's just a product that helps you statically analyze your code, and helps you decide if there's any particular code that needs improving or potentially might be buggy. There's a whole host of rules that FindBugs looks to cover, to do with all sorts of parts of the Java coding language. Things like variables never referenced, variables declared never used, those sorts of things. The next product we're quickly going to talk about is something called check style. So check style is more addressing not so much the performance or the correctness of code, but more looks at how the code is written. So what check style is trying to do is ensure that your code is all written in a way that's consistent across your developers. So the more consistent you are across your developers, the easier it is for new developers to join the team and read and understand the code. So it helps to build a common syntax, if maybe you want to look at it that way, a common syntax that your developers use when you're looking at your code. So everyone's writing the code in the same way. It makes it a lot easier for everyone to understand what other people's code's doing. The next product from the Java world is called PMD. Now PMD is very much like FindBugs, but it covers a slightly different subset of rules. One of the more interesting functions of PMD is it implements something called copy paste detection or CPD. So what CPD is trying to identify where you've replicated code manually, where you've manually replicated code rather than calling it. So if you have the same function all over the place, it helps to find where you've done that. In the case of most languages, when you replicate code manually, it means when then there's a bug found in one, then there's essentially a bug in all those different places that have to be fixed. It also means when a new feature has to be added, it potentially has to be added in multiple places. So having lots of different versions of the same code in different parts of your code base can lead to a lot of coding issues and logic issues. The next term we'll quickly cover is something called technical debt, and this is just a link to a Martin Fowler article about technical debt. And he might have been one of the first people to popularize the term. So basically, technical debt is a way of looking at the code we have now and whether or not we think it's the best possible code we could have written at the time, and where it's not, or where we think there's deficiency in the code, where we think it's not maintainable, or maybe it's not performing as we'd wish, or we think it's more complicated, or it's not as modular as we'd like. That's technical debt. So that's the technical debt is the cost that we're wearing, or the cost that we're putting onto future developers of our code by having not so much unperfect code, but code that we would like to refactor or fix. So the more the technical debt we pay down now, the easier it is for developers in the future to add enhancements and fix bugs. So the lower our technical debt, the faster, or the higher velocity we can get in, and later on in our development. The higher the technical debt, the more complicated our software generally is, and the harder it is for people to make changes and improve the code. And the slower that we can deliver new functionality. So the last two terms, continuous integration and continuous delivery. Continuous integration is where, as a team, we're aiming to integrate and test our code together as a unit as often and as automated as possible. So what we're trying to prevent with continuous integration is building silos of code that's been individually tested by one person or by one team, but then when we're actually looking to deliver the product into a working environment, we start finding issues where the code doesn't couple together correctly because it's been developed, parts of the code have been developed by different teams. So what we're trying to do with continuous integration is find bugs. So build and deploy code as often as possible, find bugs in the code as early on in the process as possible, and make sure that we communicate with our other developers as often as possible so that we're delivering quality code quickly and as easily as we can, and in small incremental chunks. And the last one is continuous delivery. So a lot of what we're trying to look at with the SonarQube plugin for Message Broker is the utopia of most development teams or most development operations teams is something called continuous delivery. And that's essentially where you set up your environment and your culture of your organization, where when you start making changes, the changes are small and incremental enough that they can be automatically integrated, tested, the quality can be checked, they can be automatically deployed to an environment, and ideally automatically deployed into a production environment with as little man-handling or manual handling as possible. So what that means is we can deliver functionality at a more consistent rate than we may have been able to do with other approaches. So I'll just stop for a second, make sure that if there's any questions before I keep going. So there's no questions. So so all these terms. So what we're looking at with this Message Broker plugin is we're looking at trying to assist our teams with being able to do continuous delivery by allowing the SonarQube infrastructure to provide us the ability to do continuous integration via our build servers, and also continuous code inspection. So continuous code inspection is very much what you do manually with a peer review. And this is just an article on continuous delivery, and the point here is the point here is point 6, where we're talking about building quality. So with a continuous delivery pipeline, where a developer can make a change, they can unit test it, they can check it into the source code repository. The build tool such as Jenkins or TeamCity or TFS will build it and deploy it into an environment where ideally you would have regression testing or some sort of automated testing. Not a lot of teams in the message record would have that, but this is the utopia. So we have that automatic deployment, automatic unit testing. The Sonar Cube and the MP Precise come in at this next step, where we're looking at the understanding the quality of the code we're developing. So in the case of continuous delivery pipeline, the Sonar Cube plugin is working at the point of just after the testing has been done, or the automatic testing has been done, before you're looking to push it into a higher environment for manual testing or integration testing. So what we're trying to do is look at the code, look at the quality of the code that's been changed, and determine whether or not we are willing to accept that code into the next higher environment in preparation for release to production. So this is an important step because the lower the quality of the code, the more likely that there are to be bugs. So also it also takes into account other metrics which may not be applicable, such as code coverage and the number of potential bugs. So all these trying to give us an estimate of how good our code is, and the better we believe our code is, either by using such a tool as this to do automatic continuous inspection, or when we're doing manual code reviews, the higher the quality that we believe the code is, the more likely we believe there to be fewer bugs. And that's what we're trying to aim to do, put fewer bugs or zero bugs into a production environment. I'll just give everyone a chance to see if anyone has any questions. Otherwise, I'll keep going. Now, the last article I'm just brought up now is something called the Snowflake server, which isn't particularly related to continuous integration, but it is an interesting or is an important take on things, because the Snowflake server is discussing repeatability. How repeatable are our processes? The more repeatable our processes are, the more likely we end up with the same end state when we repeat them. So this is important, or this is important in the case of our continuous delivery pipeline, because we want our servers and our code to be as consistent throughout the delivery as possible. So I do bring this up because there are some aspects of our plugin that will assist in ensuring that our deployments are as consistent as possible with the rules they enforce. And the last article is just a diagram of the continuous build process, or continuous delivery process. So a build, test, deploy, validate, or regression test, or integrate test, or acceptance test, and release to production. So as far as what we're talking about with Sonar, we're looking at after, potentially before the publish and after the deploy, where we're looking at test quality and code quality. So that just gives everyone hopefully a bit of a background of what we're aiming to do with Sonar. So the next couple of minutes we'll be going through a demonstration, unless anyone has any questions, and we'll start talking about some of the rules and some of the things that Sonar's doing for us, and then we'll see that come together. So So I started off by saying that the product we're looking at is a Sonar Cube plugin. So what that means for developers is it's find bugs, check style, PMD, which the tools I've mentioned for message broker developers. So it gives us that infrastructure and gives us the automatic tooling to be able to do automatic code inspection and automatic code reviews within this Sonar product. So I'll just jump in and open up this Sonar product if no one's seen it, just in case anyone hasn't seen it before. So this here is a Sonar version 5.1. Now it's the latest Sonar version. There's a number of versions that our product is supported under, but this is the current version that a lot of our users are using. So I thought I'd do the demonstration with this one, and it has the most functionality. So essentially, Sonar allows you to look at your code. So in the case here, what I'm going to do is I'm just going to run an analysis of our message broker code using the Sonar tool, which is fairly simple to set up, fairly trivial to set up, I should say. So essentially just setting up the Sonar server, allowing Sonar, checking out the code, and running the Sonar process. So basically just it scans through your source code. So when I say it scans through your source code, so what the plugin does is it looks at your ESQL files, your message flow files, your subflow files, your MQSC scripts, your XSD files, your XSL files, and your ANT scripts. So it takes all this information, builds a logical model of what your code and how your code interrelates together, and produces what we call violations and metrics. Now, violation metrics are two things we use in Sonar to help understand how our code and decide on the quality of our code. So violations are the things that find bugs, check style, and PMD report. So potential programming errors, inadequate comments in files, file lengths, complexity, various things like that. Metrics are a measurement of something about our code. So it could be the number of files, it could be the complexity, it could be the number of lines, it could be test coverage in the case of other languages, and in the case of Sonar, in the case of our plugin, we have a few specific ones related to message broker. So I'll just dive into the dashboard now. So this is the Sonar dashboard. So the Sonar dashboard is a point-in-time snapshot, showing us a point-in-time snapshot of the analysis of our software or the code we've written. So I mentioned the concept of metrics. So we'll just look over in the top left. We see we've got some message broker specific statistics. So what this is a collection of things that are important that are important or might be important to you when you're deciding about whether or not your code is of high enough quality. Now, some of these are fairly generic or fairly general. For example, the number of files, the number of lines, and the number of directories. So this just gives you an overall understanding of whether your project base or your code base is getting bigger or smaller. So an up arrow here on files indicates that progressively, as we've run more and more analysis at different points in time, that the number of files that we have in our project has increased, which kind of makes sense because most projects are becoming more and more complex. Same with lines of code. So this is just giving us just a general idea of how big our system is or how big our code is. And they're the general Sonar metrics. The message broker specific metrics, for example, the number of nodes, the number of compute nodes, the number of HTTP nodes, the number of SOAP nodes, the SOAP request nodes, the number of RCD nodes, so reset content descriptor nodes, it can be quite important for developers because they can be quite expensive to process. So we want to keep an eye on how many we actually have in our system. So when we start getting more and more, we might be looking at why that's happening, whether or not we can restructure our code so we don't need to use so many of them. flow length, which I'll come back to in a second, which relates to which can affect performance and relates to complexity of our code. Now, the cyclometric complexity of our ESQL. So cyclometric complexity is a measure of, generally speaking, the number of permutations or paths through our code. So the more if statements and loop statements and case statements our code block has, the more paths we really have to test, and the more complex our code is. Hence, the higher our cyclometric complexity is. So what this allows us to do with Sonar is it allows us to sum up our cyclometric complexity across our project, and then it allows us to dive into our files to work out which one actually is the most complex. So in this case here, it's telling that this particular example file has the highest complexity of all our code in all our SQL code in our system. So using our Sonar dashboard, we can dig into the code. And if we just look here, we can see we've got a move statement. Within the move statement, we've got a nested if with an else condition, another nested if with another else condition. So that's saying we've got a certain number of paths through our code. So this is something that we might want to look at, whether we can refactor or whether or not we can code differently to more easily to understand or more easily to test. So that's complexity. The next interesting metric for message broker developers is something called the string manipulation load. So one of the performance suggestions when writing message broker code is to limit the amount of string manipulation you're doing. So it's quite difficult for us to write a rule that tells developers to not write, or warns developers to not use string manipulation, because in most cases it's probably something that's needed as part of the logic of the code. But by providing a metric, we allow people to at least look at and inspect their code to determine whether or not the code needs to be refactored, or there might be alternative ways of handling the string manipulation, such as using Java or regular expressions in Java or something like that. So by giving the developers and the architects the metric at this high level, it's something they can monitor over time, and when they see a larger than expected value for the metric, they can dive into the console. They can have a look at the metric and decide whether or not the code needs to be refactored or not. So in this case, this is the function which has the highest amount of string manipulation in all our code. So we can say here we've got some length statements, we've got some substrings, additional substrings, length, another substring. So we're doing a lot of substring. So that's something that we might want to look at and decide whether or not this is the most appropriate way to write our code. The last metric before I get back to the flow length is something called the weighted string manipulation. So in the case of string manipulation, it's a very rough estimate of how much complexities, how much work string manipulation is doing. So just because there is a lot of string calls in a particular ESQL file doesn't necessarily mean it's bad. It depends on the structure and how they interrelate. So what we're trying to estimate with weighted string manipulation is we're taking a look at the number of string functions, but we need to also look at how and where they're nested. So in difference to the general string manipulation, what we're doing with the weighted one is we're trying to give a higher value for those which happen within loops. So potentially a string manipulation of 1, but which is in a very deep loop, may actually be a lot more computation intensive than something that has a string manipulation of 3, but has only done 1. So in this case here, we can see that I'm just trying to look here. So we can see in here we have a loop, and in the loop, so we'll just try to find it here. So in a while loop, we have, let me just try and it's a fairly complicated function, but okay, so we've got to begin and in a while loop, we have a whole bunch of trims. This is what it's saying. So this is potentially, if there are a lot of objects that we're looking to process, then we're going to be doing a lot of string manipulation work within the CSQL file. And that's what that metric is trying to warn us about, and allow us to dig deeper and understand our code better. So I've just had a question from James. Is there a way of seeing the history of your metrics? There is a way of seeing it over time, because Sonar does collect them over time. So it does allow you to, and say these red arrows and green arrows generally mean when over time it's increased or decreased. Let me just have a look. Let me see if I can find this thing called Time Machine. And because this is just a new project, this is just my demonstration one, and I've only just recently moved over to 5.1. There's not much of a history there, but it does show you progressively over time here that things have been going up. So we can see here that it was only a week ago that I really did my last analysis on the third, but we can see that since the third, generally all these metrics have been going up. So whether or not that provides you enough history, or whether it just provides you enough details to know that generally your technical debt or your duplications or your number of issues is staying steady or going down over time. But I don't believe you can actually see what issue was there yesterday in difference to what issue is there today. You should be able to see that there's less issues or more issues, but you may not be able to see the exact issue that changed. And if that doesn't sufficiently answer your question, maybe kick me an email just after this, or just stay online just after the presentation. Maybe we can dig in with a bit more detail. Now, the last metric we're talking about is the flow length. So this is another one of the combination of complexity and performance issues we look at. So what this is saying is, it's saying that the flow length of our flow, which we won't really be able to see much detail here because we don't have the broker open, or they don't have the broker toolkit open, but let me just quickly open up the broker toolkit, which I'll add alone. But basically this is looking at your flows and determining what the longest path through your flow is by the number of nodes. So this is important because it generally shows complexity if you have quite a long, detailed process in a flow, and also it helps you identify potential performance issues in the future. Because generally the longer flows, the longer the flow is, the more resources it's going to take up. So in this case here, we were just looking at backlog 6 long flows, message flows. So let me just see if I can find for the demo. Backlog 6. I think I'm looking at the right one. Let's see, backlog 6. 1, 2, 3, 4. So what we're saying here is that backlog 6, the longest path through backlog 6 is 10 nodes. So if 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this particular path here, which you may not be able to see, is our longest potential flow. Longest potential path through this flow. So if we're looking at whether or not this is going to be a performance issue, that's the path we'll be looking at. And again, these aren't hard and fast rules. These are just things that allow us to decide which parts of our code we might want to look at on top of what we might get with runtime performance monitoring. So the benefit of having this at the static analysis time is it allows us to do some of that work up front, with the aim of not having to deal with the runtime performance or detecting the runtime performance because we do have an issue. So trying to get to it early on in the development cycle. So that there are the metrics that come with SonarCube and the additional metrics that the plugin provides related to Message Broker. The next couple of minutes, we'll be talking about the issues, and this is the define again the before I do that, I'll just talk about the PMD side of things, which is what I was saying is the copy paste detection. So this copy paste detection is a sum across all the sum of the duplications of all the code in your project. So what we're saying here is that we have 6.8% of our code has been duplicated. Now with Message Broker code, it's a little bit what's the way of putting it? You have to read this with a grain of salt, because there is a certain amount of duplication that the toolkit will do for you when it creates new nodes. So your copy message headers, copy entire message type functions do show up in the duplications. But so some of these lower ones actually may just be so we're looking here at the duplications. So we see we've got some duplications, for example, here, and duplications here. Here's what it's saying. Oops. And that's just showing a violation. So, so saying we've got some duplicated lines there, which isn't all that useful because we know we're going to get a certain amount with Message Broker code. But for some of our other ones, for example, the this one here, it's telling me we have quite a lot of duplication. 98% duplicated. Yeah, so it's saying that this function here, and so it looks to be this function here and this function here are duplicated. So this is something that we would not look at because it is quite a high number. And when we first look at it, it doesn't seem to be just a simple copy and paste we get with the toolkit creating nodes for us. It looks to be logic. So it's saying we've got a fair bit, 83 lines. So it looks like the whole thing's just duplicate. And this is definitely one of the things that Sonar and the PMD implementation is very useful for, because it's not something that is immediately going to be obvious with very large projects, particularly with new developers. So it's quite possible that either new developers might grab some code from somewhere that they need to change and may be uncomfortable changing it, so they might duplicate it, or potentially they might just write the same thing a second time, not realizing that someone has already written it as a common function. So I'll just hold on there for a second and let anyone else have any questions. Otherwise, I'll keep going. So that's the metrics and the copy-paste detection component. The next component we're going to look at is the find bugs and the check style, which come out in Sonar as what we call issues. So at the moment, the Message Broker plugin has about 165 issues, 165 types of violations that it can be detected in your code. Now, that 165 needs to be looked at as not purely 165 different things, because of the way people write code. Some of our violations are actually exact mirrors of each other. So we may have 3 violations related to exception handling, for example, or 3 violations related to transaction control on flows. So particular customers have particular needs as far as how their architecture works. So some may say that every flow needs to have a transaction by default, and one other customer may have the exact opposite situation. So the same code with all the violations turned on, when you do try the product, the same code with all the violations turned on will will have potentially in a couple of places will have competing violations. So it's just a matter of working out which one's most consistent with the way you code. But what we can do is we'll dig into some of them anyway, and we'll start going through them, and then I'll give you an idea of what sort of checks that we're looking, or what sort of checks the product does, and why they're important, and how they can help you in your everyday development, or in your everyday peer reviews and code reviews. So the first one here, we're looking at, so we're looking in this file here. So we're looking here, we're saying that the default schema is not defined. So this is a check to say every, so this is here saying that every ESQL file needs to have a schema. So a name, basically a namespace. So in this case, it's saying that the namespace that you're provided, or you haven't provided a namespace. Now later on, we might actually find another example around namespaces, which mean another violation we actually allow people to have when they set up their properties. And I'll just quickly show you the properties file. Okay, demo. So we'll just quickly look at the properties file. Now the properties file is just generally the basic configuration that you need to have when you run an analysis, but it also allows you to put in additional things related to particular plugins. In this case, our plugin has something called an ESQL default schema name. So what we're saying is when you set this up to run in your company, if you work for company ABC, you might want to say that every ESQL schema has to be in the package, or the equivalent of being in the package de.com.abc.integration, for example. So when people try and put things in a different package, it allows our plugin to look at this property you've set up as saying where everything should be, until you haven't put it in the right package, or in the right schema, I should say. So that's a structure of your code check. So this particular structure of your code check doesn't affect performance, but just helps your developers understand the code better and structure the code better if everyone's putting things in a consistent schemas. Okay, so the next check we're talking about here, we're looking at here, is a header file should contain author, version, and date. So this doesn't help us because it's not showing us much in the way of code, but let me just see if I can expand the code a little better. So what we're saying, well, okay, in this particular case, we're looking at an empty file, which is it's also saying, by the way, you've got an empty file. You probably shouldn't have checked your empty file because it doesn't do much. So these next two violations we're looking at here. So header file should contain author, version, and date, and header does not contain test company name. So again, looking at the properties for the second one, what we're saying is that every ESQL file that you create needs to have some sort of company standard comment or company standard documentation in the header. What this allows you to do is put copyright material or licensing arrangements, or just your company name in the file, just to make sure you're getting a consistent documentation for each schema file, ESQL file. The second one here, or the highlighted one here, header file should contain author, version, and date. This is for companies that use particular version control systems, such as Subversion, where Subversion will insert the author, version, and date of the person that changed the file last. So by having this as by having this in all your files, it helps you to get a bit more of an easy history, or a visible history of what's happening in the file. So again, these aren't things you necessarily need to do if you decide you don't particularly want to have author, version, and date in your files. You would just go into your Sonar profile, which I'll just show you here. I'll just go into your profile. Oops, sorry, that's the wrong one. You go into your quality profile. Rules. And you would look for the rule. For the rule. And there's the rule, and what we do is you would deactivate the rule. So the next time that particular analysis run, that rule wouldn't have a violation because you've turned it off, or you've changed the priority. So if you look at this rule here as is set as major, so you can set it to minor or trivial or a blocker, depending on the priority you want to have. So we'll just go back into our issues again. So we're just looking at working through our issues. So file is empty. So we'll go through things unless anyone's got any questions. We'll just stop to see if anyone got any questions. We'll just quickly go through a couple more. Otherwise, we're going to get to the end and we won't have gone through all the functionality. Event trigger. Okay, so in this case here, okay, we're looking here. The input node has no catch handler connected. Errors may not be able to be tracked or may be lost. So in this case, we're looking here at backlog one flow timer. So we're saying we've got no error, no exception handling on our timer controls, and no exception handling on our event trigger. So if there's an issue, it's gonna drop the message back to the dead letter queue, or retry, depending on how you've configured your queues. So some organizations prefer to have some sort of exception handling on all their inputs. Other organizations prefer to allow the environment to run it to support exception handling and retries, and would prefer not to have an exception handler. So you're looking at the same piece of code, but it may or may not be a violation depending on how you want to do it. In this case, it's saying there is a violation because there's no exception handler. So that's a flow example. For example, here, missing transaction start. That's let me just go through some more. No catching. The input node has no failure handler. So again, we're talking about exceptions again. So we'll go back here. So that was issues. So we'll go back into all of them. So input node pass timing. So we're saying that you want all input nodes should pass in time message. Make sure that it's valid. In this case here, the compute node never creates an output message. So essentially, you've got the nodes, the incoming message to say message content and message, but you're not actually using the message. You're not creating a message. So it's a little bit of overhead. Either it's potentially a logical error saying you should be manipulating the message, but you're not, or the other alternative, it could be a performance issue where you're saying, well, you've set up to pass the message, but you don't need to use the parser message because you're not actually using it. So you can use a different parser, or you should not use a parser in that case. So in this case here, we've got a particular check for a client that's decided they don't want to use ESQL at all. So every time someone checks a node with an ESQL type node in or compute node in, it tells them you're not supposed to be using compute nodes. And we've got the alternative, or the opposite one for that. We've got a check that says, well, whenever you use a Java node, it tells you not to use it, or warns you that you're using a Java node, because the architecture they've decided is not to use Java nodes. This one here's another documentation type one where we said, well, there's an architecture decision that every flow should have some sort of documentation as part of a note. So by not having a note, you're not documenting it. So we're saying that you should have. This particular check here is to do what we were talking about before when we raised the Martin Fowler issue around the Snowflake server. So what we're saying here, so this particular one here is where we've said that we don't have a build configuration that includes all the subflows. So we've got a subflow, but we haven't listed anywhere to be built and deployed anywhere. So what that means is someone may be manually, either this flow is actually redundant and can be deleted, or someone has been manually deploying it and it's not included in the automated build script or the automatic Ant script build system. If it's not part of the automatic system, then there's a potential that it will show up in environments because it's been done manually and work, but then when it goes to production, it won't work because it was never automatically put in there. So this is just a check that we have between the Ant script and the list of flows to say, are all these flows going to be deployed? We also have the similar check for queues. So we look through the MQQ definition file and try and match them up against queues within the flows. So when we have a queue used in the definition file or name used referred to in the definition file that is in the flow, could either mean the queue's not is legitimately not required, or it could also mean that the queue is actually misspelt, and vice versa, whether it's a queue used or defined, a queue used in a flow but not defined in the queue definition file. Either we've got a potential for an issue when we do get to production because we haven't created all the necessary queues, or we've got a misspell or a logic error where we're expecting the queue name to be slightly different. This one here was suggesting we use the XML-NS C parser over the XML-NS parser because it's more efficient and performs better. And there's a few other checks in there to do with redundant nodes and redundant ESQL methods such as bitstream. So I haven't really covered all of all the violations that the product produces. So there's about 165 of them, and some of them can be quite detailed. But hopefully, it gives you everyone an idea of the sort of things that you'd be trying to look for. And in this case, Sonar's doing it automatically for you. So just take a step back. So we've covered the main parts of the Sonar Cube in the Sonar ecosystem, which is the violations, the metrics, and the code duplications. The next one is to do with a little bit of value-added work that we're providing as part of this plugin, which is to do with diagramming. So most people have started in existing projects which have been running a long time. It can be quite difficult to get your head around and understand where the architecture fits and where all the components and how they all integrate together. So the toolkit does have the ability to produce diagrams of individual flows, which is very much what you'd see in the toolkit anyway. So I'll just produce you a sort of a diagram in print form of that. What we've tried to do is take the information that we've needed to build out these rules and violations and metrics, and take that and develop documentation that's constantly updated every time the project runs. So in this case, when I've run the project has ended up producing some files in this directory configured by the properties file in this flow diagram output directory. So what I have here is just running a local web server called Mongoose, and I'm just looking here at what's been generated. So the plugin will generate a whole bunch of files, and the main one is the generated HTML page. So this generated HTML page is the entry page. So what we have here, or what we're looking at here, is a diagrammatic representation as an SVG diagram of the interactions between the different message flows via queues. So what this is saying, and if I just zoom in here for a second, and hopefully we'll see if the pan works. The pan and zoom works. So what we're saying here is, So what we're seeing here is this particular flow here, for example. And you might not be able to see this because the screen resolution is not great, but what we're saying here is there's a flow called drawing circular, and drawing circular takes a message from the drawing circular, the DC queue, which feeds back into the DC queue. So what we're saying here by the line, by the circular reference line, is this flow actually takes a queue out of a queue, takes a message out of a queue and puts it back into the same queue. Not sure why it might be doing that, but it's just trying to indicate that's the logical flow. So that gives you an opportunity to drill into the summary, let you look at the documentation that's been defined in the notes and other parts of the flow, and then we'll show you the interaction. So it's saying it's coming from drawing circular to a queue, to a flow, back to a queue, and back to a flow. Not so useful for single message flows, which in this case here you've got a not so useful for single message flows, but in this case here, so the rest of these here are interactions. So what we're saying is something, there's a thing called flow form message flow that produces messages which are consumed via queue, compute out by another one, by another message flow. So this gives us, in this case, some of these more complicated ones, it gives you an idea of where the flows are going and where the message is going through the business flow. So looking through the toolkit of the single flow, we just get an idea of what a particular flow does. In this case, we're trying to look at all the flows and how they relate together. So in this case here, you can see that a message comes from something called start queue, goes into a flow, and the flow itself will propagate a message to one or more of these queues. So Q1, Q2, or A. In this case here, we're looking at Q2 is actually messages are consumed by both drawing 2 and drawing 1, which could indicate that we've got an architectural issue because we've got a race condition where the same queue is being consumed by 2 different flows. So depending on whether or not that does what the business, the logic of the business case or the logic of the business requirements, that may or may not be an issue. But it was something that definitely, as an architectural designer, you might want to look at and see whether or not that's consistent with what's expected. So that's the diagram component. So it gives you a chance to navigate around your flows, but more from a business context. The other half of the diagramming or the diagrammatic generation is the summary or the summary table. So in this case here, we're just summarizing some information about our project based on the flows, the queues. So here we are as a list of all the flows and all the comments in the flows. So this here is 1 to 10 of 46 entries. So what we'll do is we'll just put 50 to a page just so we can see it. So this here is helping us to understand a little bit of additional documentation about our flows, but also it also allows us to see all our flow names in the same place and all documentation in the same place, so that if we do decide that we want to have a naming standard, we can see what all the existing names are, and then we can see which ones we might decide are not according to our naming standard. The queue summary, a summary of all the queues in the system. Again, this helps us look at our this helps us look at our naming standards. It allows us to have an idea of how it integrates with our system. So if we know that we want to look at a flow, then we know that's there's a relationship to a queue, or there's a process affected by a queue. Also, if we just want to find some additional information about our queue, this will help us find it. Now, there's the 4 columns on the right, the alias, to indicate whether or not queues has an alias defined. So we just sort by alias, and we'll just see. Taking a list. Okay, so we'll sort by alias, but there's none there. Okay. So, but just by clicking on the title bar, you can sort. In this case here, there's none of these queues are represented by or have associated aliases, which you need to look at whether the alias is used, not just the queue. But in this case here, it's trying to give us the information about how this particular queue is used. So in this case, we're saying that this queue here is not used by message broker, but it's used by data power. In this case here, we're saying that this queue is used by message broker. And then we'll see if we can find a data power, and we'll see if we can find a Sterling and data power one. Yes, so this tries to give us that that business contextual information of what's being used by message broker, what's being used by data power or Sterling, and where our points of integration are. So where a queue is read by message broker and written to data power, this will show up in this table here. So I'm just going to be aware. Sorry, I do apologize for we're running out of time here. So I'll just go through some of these other features a little bit more quicker, just to make sure everyone can get back to work or the next important meeting. This table here is the SQL summary. So the idea of this is it extracts all the SQL out of or your SQL, your style sheets, in the case of data power, and your flow files, and it manipulates or rebuilds the SQL into purely the SQL version. So here we've got the original SQL that might come from an SQL file, and then this is the SQL that's created, that's actually being run against the database. So this here is a way for developers and DBAs to work together. So this gives the DBAs a point in which that they can start reviewing what the message broker's code is going to be doing to their databases without having to run all the permutations. So in the case of most database DBAs may monitor the performance of the database, and they might look at queues that are running a particular amount of that are taking particularly long, or doing table scans or whatnot. This allows us to get the same screen up in front of the DBA and the developer and get them together looking at these potential issues and the query design well before it gets into a production environment. So not saying that the other way of managing this by looking at performance logs and whatnot isn't valid, but this allows us to do it for all the potential SQL, not just the ones that are the biggest screamers on the day. So again, it's working as a collaboration tool, try and get that conversation going on. The rest of these are just general summaries of, for example, all the data sources properties, all the Java methods used, all the stored procedures that have been used, the file system files that are being read. So it's saying that we're reading some files from broker, we're writing some files from broker, and this is giving us an idea of what the files we're using. So in the same way we get the integration between where a queue affects the flow, we can look at how a particular file is being used. What particular flow might be producing a file. Incoming URLs for using broker as a server or a service. Exceptions. So we're looking at the exception codes, exception numbers. So this is useful for just consistency, just to making sure that the wording of the exceptions is consistent. And trying to develop a standard if you don't have a standard already. Input data power URLs, output data power URLs. So essentially, is where data power's working as a server, as a service, and where data power's calling out to other services. So just to get an idea of all the different points of communication and integration. I will just spend a little bit more time just talking about this one here. So this one's the common SQL. So what we're looking at here is trying to work out which SQLs what we call as common, so not really living within a module and potentially going to be reused, and hence more likely to be useful for new developers and more likely to be useful as sort of a glossary or a library of common functions that can be that can be available. It also gives also works with what we're saying before about copy paste detection. So if we've got a whole functions that kind of do the same thing but are in separate files, it might give us a point to collapse some of that logic and refactor the logic so that we have some more commonality there, and we have fewer permutations we have to test. But anyway, so what we can do here is we can just look into the code, and this gives us just a summary of what the common ESQL is. Oops. So yeah, so where we do have common ESQL, it allows us to see what it is, so that we can decide whether useful for new developers to say, well, that's a useful function, I might need to use that rather than writing my own. And in the last minute, we'll quickly go into where the continuous code inspection sits within the build process and the continuous delivery process. So we're saying that in our utopian environment, we have a check-in test, or check-in regression test, code quality review, which is where this plugin comes into its own, and then deployment. So in this case here, just for an example, we've set up our own Jenkins server. In this case, we've got a Jenkins job, and the Jenkins job is to essentially just run our Sonar analysis. So we just look here, and we'll just look at our Jenkins job quickly. And we'll just look at our output. So essentially, our Jenkins job is just checking out our code and then running our Sonar analysis against it in an automatic manner. So this is something that you could do before or after. In this case here, we might just need to so say here I'm looking at a slightly older version, so I'm looking at a let me just quickly configure this. So I'm actually looking at version 4. So we'll just look here. Okay, bad example. So this here is our Jenkins job. What it should be showing is that when we finished running our analysis, that the analysis has been run, and then we've got these things called quality gates, which are part of Sonar. What that means is when we actually have more than a certain number of an issue type. So what we can say when we have more than a certain number of criticals, or we have a certain number of open issues, where we have a certain number of blockers, or a certain amount of unit testing. If we are above or below whatever threshold we've defined as our minimum quality criteria, we can actually tell Sonar to actually break any builds using something called the build breaker. So what that means is if we did integrate Sonar, and which some of our clients have done, if we do integrate Sonar and the plugin into a continuous delivery environment, you can actually stop the code once it's been received from the developer going into, say, the development box for integration testing or acceptance testing by BAs or testers when the code quality is fallen. So if a developer is doing something they're not supposed to have done, so they've breached some architectural policy, or they've just got some performance issue, which we deem is serious enough that we don't want that code going out, then we can stop that code here. So we can stop that code before we've had spent all their time and if it had testers test code, which we know won't go to production because it isn't of sufficient high enough quality. But if someone does want to see a bit more details on the build breaker and that quality profile, I can just change the subversion checkout path, and hopefully it should work. Anyway, so that's our hour up, and maybe a few extra minutes. So hopefully I haven't made anyone late. But yeah, hopefully it gives you everyone some ideas of what sort of things you can actually do with some of these tools, such as Build Breaker. And even if you're not working on message broker code, Sonar itself is a good product, or Sonar Cube is a good product to help develop in pretty much most languages. So Sonar Cube itself is a rich environment. I'll just see if I can find the so you can just Sonar Cube languages. And it does support a whole number of languages. So some of these come out of the box, and some of them are third-party commercial ones, like our plugin. But if you're doing .NET or C#, PLSQL, PHP, Flex, a whole bunch of different languages, it does help and aid your development by providing a second set of eyes or a previous set of eyes for doing code reviews. So in the case of what we're talking about here, we're not trying to replace the peer review or the code review process, but we're trying to do some of that manual lifting that humans aren't good at, like sometimes checking names against patterns and things like that, or in the case of code duplication, it's quite difficult to do manually. So that once you have passed all your sort of mandatory code standards and coding policy checks, your code reviews can be more of a structural and architectural and more value add for the developer, rather than just things that they could have fixed quite easily had they'd run an automatic tool. Anyway, so I'll leave everyone to get on with their day. Hopefully you've all enjoyed it, and we'll be taking we'll be pulling a steak dinner out of the hat as the lucky door prize, and we'll be sending out an email in the next couple of days to notify the winner that they've won a steak dinner. Thank you for joining us. Thank you for allowing me to present our plugin, and hopefully you all got something out of it. If there's no more questions, I'll just be leaving the screen as is, but just please jump onto chat or send me an email if there's anything that anyone wants to ask about.